So in this video, we'll be talking about what is basically we can think of as reduction. We saw that there's an idea that the physical is just whatever fundamental physics discovers, but there's a way in which that's too limited because we think that water and life and fire are physical, but they're not sort of straightforwardly discovered by physics. So we want to understand, well, in what sense are they physical if we're being guided by fundamental physics? And the reason we're interested in that question is because it's going to help us understand, in what sense might the mind be physical? And that's what we'll be talking about in this video. So let's think about water as an example of reduction. So chemistry has discovered that water is mostly made up of molecules, of H2O molecules. When you encounter some water, what you're looking at is in fact a bunch of H2O molecules and some other stuff too mixed in there, but predominantly H2O. And what is H2O? Well, H2O is two hydrogen atoms bonded to an oxygen atom. So when we say that water is H2O, what we're saying is, well, there are these molecules which are made up of two hydrogen atoms and an oxygen atom, and the water is a lot of that. And hydrogen and oxygen and the bonding that they undergo to create H2O, those are all defined in terms of fundamental physics. So when we look at water, although this wasn't known for almost all of human history, in fact, what we're looking at is a bunch of these atoms of hydrogen and oxygen atoms hooked together in H2O molecules, tons of them bouncing around against each other, as well as probably some other stuff in there like oxygen by itself and maybe salt and other stuff, but mostly H2O. And so while fundamental physics might not itself talk about water, we can define water in the terms that fundamental physics gives us. Similarly with fire. So when we look at fire, it's red and it's bright and it's crackling and it gives off heat. It turns out that fire can be defined as an exothermic oxidation reaction with some other sort of, and a few other terms, again, that we can fundamentally define in terms of fundamental physics. So fundamental physics can tell us exactly sort of, okay, here's what, when there's fire going on, here's what's happening with the subatomic particles, and that's, whenever that is, the subatomic particles are doing that, then there's fire. And so we can define fire in terms of the fundamental physics. So really, there are at least two ways in which things can be physical. Either it can be the kind of thing that fundamental physics itself investigates, the particles and the forces and the fields and whatever else come up in that investigation of how that stuff behaves, or it can be things that we define in terms of that fundamental physics. So water is H2O, fire is exothermic oxidation, blah, blah, blah reaction, or however exactly it might go. But there's a little bit of a complication here. Let's think about life. So life is a physical phenomenon. It happens in and to physical things. It's hard to define life. There's no widely accepted definition of life, but here's sort of a stab at one that we can use to help us understand what we need to understand about how life can be physical. So here's the possible definition. A living being is an open system, meaning that it interacts with stuff outside of itself that maintains homeostasis, so it maintains its own internal state. Basically, it's composed of cells. It has a life cycle, so it is born, it ages, it dies. It undergoes metabolism, so it takes stuff from the environment and turns that stuff into part of its body. It can grow, it can adapt to its environment, it can respond to stimuli, it can reproduce, and it can evolve. That's what a living being is, you might think. Something like that, anyway. We're not going to define that in terms of fundamental physics. There's no particular sort of set of interactions among particles that we say, aha, whenever those are happening, then this process, all these living processes we just described are happening, and vice versa. So we're not going to take this definition of homeostasis and cells and life cycle and metabolism and so on and just replace it with terms for fundamental physics, right? With water, it's pretty straightforward. We just say, oh, it's H2O, and those are fundamental physical terms, but there's nothing like that we could come up with from fundamental physics that we could just replace this definition we have here on the screen. So how is it then, if we can't define life in terms of fundamental physics, that we want to say that life is nonetheless a physical phenomenon? Well, let's think about metabolism. So when you metabolize, you eat and you digest and you excrete. So when you eat, right, well, your teeth sort of smash down on stuff and it breaks it down into smaller pieces, and then those smaller pieces move down your throat and into your stomach, where the stomach acids break it all up even more, and then that stuff moves into the digestive tract, where some of it gets passed through the walls of the digestive tract into your body, and the rest of it gets pushed out. And all of the stages of that can actually be explained in terms of fundamental physics. So when you eat something, right, well, there are the molecules in your teeth that hold your teeth together, and they're stronger than, hopefully, than whatever it is you're trying to eat, right? If it's, some chicken or some lettuce or a carrot or an orange or a candy bar or whatever it might be, your teeth are stronger than the stuff that you're eating, and that's why your teeth can break it up. And we can explain can be explained in terms of the atomic constituents of your teeth on the one hand and the meat on the other hand, and that's why trying to eat a rock is a bad idea, because the rock is harder than your teeth, and that hardness is explained in terms of the atomic constituents of the rock. And we can make similar observations about the rest of the process. So for example, when the food is in your stomach, we can talk about the chemicals that are involved in acids and the chemical composition of the food that explains why the acids are able to break that food down even further. And then when the stuff moves into your digestive tract, we can talk about how the walls of the digestive tract and the way in which they're made up out of subatomic particles and molecules allow certain kinds of chemicals, fats and acid and proteins and sugars to move into your body and prevent other stuff like, say, fiber from going into your body. So we can explain what happens in the metabolic process in your body by talking about the chemicals and so on, and the chemical composition of everything that's involved in the process, and the chemical composition is itself explained in terms of the subatomic physics. When a bee metabolizes, something else happens entirely, right? It's involved with pollen and nectar and so on. I don't really know the details, but they're rather different because it's a very different chemical process, right? We don't have teeth, for example, in bees. And so we don't have to explain how the bee breaks up its food in the same way. But nonetheless, in the case of a bee, we can explain the whole metabolic process in terms of the chemical constituents of the food, and then the chemical processes are then explained in terms of the fundamental physics. So all this stuff, your body, the food, the bee, its food, it's all made up of subatomic particles, and in each case we can explain what's happening by talking about, in the end, the subatomic particles. And so and that's true for homeostasis and being composed of cells and having a life cycle and growing and adapting to the environment and all the rest of it. So in any given case, when we look at what's happening in a living being and the processes that account for life, we can explain it all in terms of subatomic particles, and that's why life is physical. We don't have to introduce any further mysterious life force to explain what's happening. So when we talk about something being physical, there are really sort of three different things that can make something physical. One is just it's the kind of thing that fundamental physics discovers. The second is that it's the kind of thing that fundamental physics defines, or can be defined in terms of fundamental physics, like water being H2O. And the third is that it can be explained in terms of fundamental physics, like we can explain life processes in terms of fundamental physics. And these latter two are what are called reduction, because in a sense we're saying here's this thing that doesn't look like it's part of fundamental physics, but actually in a fundamental way it is. We're reducing this. What's really there is just all the subatomic particles dancing in fields of force in the void, and their behavior is actually everything else can be defined or explained in terms of their behavior. So when we say that there's a reduction, we're saying in a sense there's not anything fundamentally new. Life isn't something fundamentally new. There's no new forces involved. It's just subatomic particles behaving in certain really interesting and complex ways, maybe really important specific ways, but it's all still just the behavior of subatomic particles. So extreme physicalism would say that's true about everything, that everything is physical. Is extreme physicalism true? Well, that's a good question. But what extreme physicalism says is everything either is what fundamental physics itself discovers, or can be defined in terms of fundamental physics, or can be explained in terms of fundamental physics. And physicalism about the mind is part of extreme physicalism, and it says that the mind, mental states, events, processes, intellect and emotion and sensation and memory and choice can all be explained in terms of fundamental physical particles and fields and forces, just like we do with life. And the question is, how then can that happen? And that is what we will be talking about in the last videos in this module.